All right, welcome back, folks. Thanks for joining us as we reconvene for the afternoon portion. We had a couple of good highlights for the morning portion. We went over the hybrid definition, clarified that as one resource ID construct. I think the key there was that point, as well as the minimum size requirements for the 500 kilowatts and 100 kilowatts for the vert component and storage component, respectively. And I think we went on to the business and use cases discussion and talked about the business drivers that folks may find attractive for configurations for the ISO markets. And I think we had black start and outage configurations was another suggestion that we got from folks on that. It's very helpful. And then we went on to the forecasting discussion. As folks know, we are proposing that folks self-submit their forecasting schedules. We had some good input on that. And then finally, we talked about the market systems and how we would be implementing some sort of, or proposing to implement some sort of interconnection constraint for co-located resources. And that's pretty much the major highlights of the morning. And with that, I'll just hand it over to Chris to continue the discussion.
All right, thanks, Jimmy, and thanks to everyone for joining us again after lunch. So we're going to pick back up a little bit more on the markets and systems discussion, try to wrap that up, and I think we're close to the end of those slides, so we should be in pretty good timing to stay on schedule, maybe wrap up a little bit early, but I think, more to come. I'm also going to talk about our our metering and telemetry proposal, and then also our ancillary services and the RA aspects of the proposal. So those should be pretty good discussion as well. So to get back into this discussion on the interconnection rights, we wanted to talk a little bit about the timing of this. So we want to do the interconnection rights constraint. Again, this is for the co-located resources, meaning the resources at the same POI with two separate resource IDs. And so we had some good discussion on this earlier in the morning session, and a lot of questions. I think we've got some more ideas about what people are thinking and some good feedback there. But one of the things we wanted to discuss and let folks know is our current plan for the implementation timing. And I think the idea that we might have to have some kind of interim solution or how we're going to address it in the meantime is something that obviously a lot of stakeholders have asked about. So that's where we wanted to start off the afternoon discussion on, just to wrap up this discussion on the markets and systems proposal. So the interconnection rights constraint timing on the implementation, previously we were discussing this in the issue paper, that we wanted to try to get this in place in fall of 2020. We talked a little bit about this earlier, in the morning session, where I think Susan Schneider asked about the potential for doing something in the interim, and so what we determined is that if we add in the AS solution, where we're optimizing both the AS and energy from co-located resources to limit it to their interconnection rights, it would actually be a pretty big lift to the point where we think we have to move that overall implementation to fall of 2021, and it won't fit in as easily as we had priorly discussed previously with stakeholders during the issue paper phase. So with that, that's what's kind of driving us to say, okay, what can we do in the interim? So to address this interconnection limit issue for these co-located resources, what we're proposing is just to continue to keep the current approach where we're limiting the PMAX of those co-located resources to a total of their interconnection rights. So what does that mean? Essentially, we're still going to have some possible stranded capacity on resources in the interim. We understand that that's a big issue for developers, so one of the things we're trying to work out and we think might be able to provide a little bit of relief to that issue is what we want to do is work with the developers to actually select the PMAX of the resource for each of the co-located resources so they can have a choice in how they would split that up. So, for instance, if you had perhaps a need to want to have more on the renewable component of a co-located resource, so let's say there's a solar resource and a storage resource, and their combined interconnection rights was, say, 100 megawatts for both, 100 megawatt resources. then perhaps the resource owner might want to split up those overall interconnection rights in a manner that's not just half and half for 50 or 50 for each. Maybe they want to do like 90-10 or 80-20 or something of that nature. So that's one thing that we think we can do easily without having a huge, implementation lift. Obviously, that's going to be part of our NRI process, a master file process. So that's what we think. One way we think we can, address some of this concern. Because, obviously it's our understanding that people will probably want to have more of the PMAX probably on the renewable component because that's going to be producing, up to a higher level most of the time, perhaps. So that's one thing that we were thinking might be able to provide a little bit of a relief on this. But the other thing we wanted to note is we thought about, is there something else we can do in the interim? Could we rely, currently we have in our interconnection GIAs, we have a limiting scheme requirement where if you have an oversized resource already, even if it's just a single resource not co-located, you actually have to have a limiting scheme in place to make sure it doesn't go over your interconnection rights. So we wanted to think maybe we can just rely on such a thing as that. We thought about it, and we thought maybe we can propose some kind of a tariff requirement that would say you can't bid above what your interconnection rights would be. It might sound good on its face, but there's a lot of complexity associated with that, which is why we're not proposing that. So we considered it, but we're not proposing to do that because we can't implement the control and system changes that would be needed in a timely manner. So that's why we're going with the interim approach of just continuing the kind of the status quo with a little bit of flexibility as to, the PMAX and each of the resources. So, to do that bidding concept where, the forecast of the VER could be varying and the amount that was actually bid might not match that. So we'd have to have some kind of controls in place, and it just didn't seem like having the ability to update our systems in a way that would actually allow us to really make sure that folks weren't bidding above their interconnection rights. It was too onerous to actually propose to do something in the short term. So that's where we are on this interconnection limits constraint in the interim. So that wraps up the discussion on all the markets and systems proposal that we wanted to talk about. But I'll give another opportunity for some discussion on this interim approach, see if anybody has any thoughts or discussion. Sure, go ahead, Doug.
Yeah, Doug Bocignone for Cal CCA. Just a couple questions on the split between the resources for within the 100% limit. Would that be something you could update periodically, or is this like a one-time decision?
You can change your master file parameters, but it takes, my understanding is it takes about 7 to 10 days to do so through our process. So it wouldn't be something that you would be able to do like dynamically on a daily basis or dynamically on a weekly basis, but you could change it, periodically, I guess is the time frame I would say. I think to do that, we would have to probably think about what kind of requirements we need to have for ensuring that, folks are making sure that kind of goes through somewhat of like that new resource implementation process where we ensure that it's limited to its interconnection rights and people aren't just going in there and updating their PMAX randomly or anything like that.
Okay,
but yeah.
So that's helpful. So, yeah, and you referred to developers, but would it really just be the scheduling coordinator for the resource would be the change?
Yeah, perhaps that's more appropriate. I think, whoever the owner-operator of the resources, I think that's really what we intend.
And then it seems like with this limitation, that might create a little more interest in the hybrid solution to get around this, at least for a period of time. So are you envisioning that you could change from one, either being co-located to hybrid or vice versa?
Yeah, I think we are. I think we do envision that folks might want to select one and then move to another. There might be reasons other than just this driver, perhaps like the ITC stuff. People might want to have one combined hybrid and then later switch it to two. So yeah, you can. Under our process, you could change. It would take you going through that, I believe, through that NRI process again, and I don't know the exact time frame, but it's somewhere around 3 months or so to get that process in place. So it's not something that would happen regularly or on a quick, super quick basis, but relatively quickly you could change over from a hybrid resource to a co-located with two or vice versa. All right, anyone on the phone? Operator?
We do have a caller in queue. Caller, your line is unmuted.
Hi, Susan Schneider, Phoenix Consulting. Thanks for responding to those earlier issues. I had a couple of questions, sort of follow-up questions. Actually, one follow-up question to your conversation with Cal CCA and Doug. If usually going through the NRI process is more like 7 months. Are you envisioning that if you made this kind of change, it would just sort of be a truncated version of that process?
Maybe that was just my misunderstanding on the time frame. Oh, okay, yeah. So, Riddy here mentioned that it is 203 days. Sorry, not.
Okay, you have to go through the whole process. Is there any way the ISO might be able to develop, just because it seems like a lot of the other things would already be in place, is there any way the ISO might be able to develop a more expedited way than making them go through everything from the very beginning and taking such a long time?
Go ahead, Deb.
Yeah, Susan, it's Deb. We would definitely go ahead and take a look at that. You're right. The challenge will be is that especially if you're going from one resource ID to two, you're going to have to change all of the schematics. You're going to have to go ahead and come up with a new metering scheme. You're going to have to go ahead and provide additional data. So we'd have to see how that works in. Plus, it will impact the network model, so there has to be a model change. So maybe not 203 days, but not 90 either.
Well, I'm thinking a lot of people,
somewhere in between.
Because of the stranded capacity issue, I think what you're going to see is a lot of people who are going to come in, if they come in this interim period, they're going to meter everything and put everything in place to use two resource IDs potentially, but they're not going to start that way because the stranded capacity issue is so devastating economically. So anyway, it would be good to, if you can take a look at that, I'd really appreciate that. Okay, let me ask another question.
So
go ahead, sorry.
Susan, yeah, before you go along, I do want to also note, I think it is important to think about, because I think your statement about how everyone's going to want to go in as a single resource ID hybrid, these changes that we're proposing for how they would provide forecasts and such, those aren't going to be in place either. So in the interim between now and when we implement this whole proposal, if you do come in as a single resource ID, then you're not providing a forecast, and your upper economic limit is not going to be updated the way that we've been discussing it today. So you'll have to provide bids like it's a traditional resource, but you won't be able to update that that upper economic limit in the interim period. So that could possibly present a large risk for not being able to meet the market awards as well. So I think it's to be seen as far as what drives what, because I think there's going to be people that still want to do the co-located resource ID, even with the idea of the stranded capacity. So I just wanted to make that point very clear to everyone.
Okay, yeah, you did not say that upper economic limit was also going to be not going to be in place until 2021. So that is a very important clarification.
Yes, and I was going to discuss that a little bit later, but since you brought it up now, I thought that was important to recognize now during this discussion. So I do think we're open to considering how we can maybe address something else as far as the timing on that might be able to be done quicker. So we'll take that back and have more discussion internally about when we could actually get that in place, and maybe we can update our time frame. But right now, the overall implementation time frame is still scheduled for fall of 2020 for the whole proposal. So.
Okay, good clarification. I have one or two more. We have one or two more clarifying questions. I apologize. But so currently, you were talking about this 100 megawatt project that had 100 megawatts of solar and 100 megawatts of storage, and you split them into 50 and 50. Does the current system automatically do some kind of proportional split, or do they do what is that how it works now?
So we don't have any of them in place right now, so we've never done it. So
okay, so this idea that they'd be able to pick. Okay, so this idea that they're going to have the ability to pick and allocate it in whatever way they want. First of all, is that also a 2021 thing?
No, I think we could do that easier. That one doesn't actually cause any system changes or anything. That's more of just a process change where we would have that discussion, you know, with when we do our contracting folks. Go ahead and add to that, Deb, if you'd like.
Yeah, Susan, what we do is we go ahead and establish that as part of the NRI process when we go through the finalization of what gets put into the master file.
Okay, so right now
we can do that today.
Okay, so they can do that. So that's not a new feature. That's just continuing something that's already in place.
Well,
right?
it's a new feature from the perspective. It's a new feature from the perspective of we've never had to do it before. But the NRI process in determining what goes into the master file is something we've been doing for years.
Okay, and so, but I guess what I'm saying, if somebody was going to go online tomorrow, or I'm sorry, go into the NRI process in order to go online, they can make this choice today.
Correct.
Okay, all right, that's good to know too. Okay, and then my last question has to do with the idea that if you have two different resource IDs, and one of them is a VAR resource, and today the VAR resources, if they're dispatched to a certain level, they're actually allowed except under some certain circumstances, they can generally produce as much as they're capable of and can go above the dispatch instruction. Is it a violation of something if they go above their PMAX that's in the master file without an instruction? I mean, it would never be instructed to go above the PMAX, and I think that's understood. But let's say in this your 100 hybrid here, and this VAR has a PMAX of 50, they're never going to get dispatched over 50, but can they produce 60?
They can only, Susan, it's Deb again, they can only produce the maximum that is in their generator interconnection agreement. So you can't go above that number. And
okay, but that's the total for both. Yeah, that would be the total. That would be the total for both, which would be the 100 total in your example here. Okay.
Correct.
So if they have 50 and the non-VAR part has 50 as the PMAX, and then let's say the non-VAR is producing lower than 50. Let's say the non-VAR is producing 40, and the dispatch instruction to the VAR part is 50, but there's that sort of other 10 that's kind of out there. Could they produce at 60, even though the PMAX that VAR was assigned in the master file is 50?
So they're deviating above their PMAX.
Yeah, and they're allowed to go above the dispatch instruction, but are they also allowed to go above? It's not above the PMAX for the whole resource because that's not violated, but could they go above the PMAX in the master file?
I'd have to talk to operations and see how that's handled today.
Okay, because that might be one way to mitigate. That might be one way to mitigate the issue here. If they couldn't get a dispatch instruction, but unless they get one of those special circumstances where you're not allowed to go above the dispatch instruction, if you could maybe take up some of that slack, if there was any slack, by going above the PMAX for that resource, but not the whole project, that would actually be a good mitigating factor if you can get that to work.
Yeah, but Susan, the challenge will be that will be on an honor system. And so then the CAISO is going to have to put something in place that checks to make sure that people aren't going over what they're allowed as their point of interconnection.
Well, yeah, because they already have controls. They already have to have controls. It says in your 100, 100, 100 example, they can't go above the 100 in total because there's going to be controls preventing that. Okay, so one of them goes above while the other is below. Yeah.
I will tell you that operations did a little check in February of this year, and we had 148 units that were over and above their point of interconnection. So 140 units got letters from me telling them that their controls were not working properly and they needed to work on their controls. And we've had ongoing conversations. So we are very weary of telling people that it's okay to go above your PMAX as an uninstructed deviation, because then there's a game that you could play that you can go up higher than what your point of interconnection is.
Well, I think that is a separate issue, and of course the ISO should be enforcing that, okay? But I'm not talking about that situation. I'm going to say the controls are working perfectly. So anyway, I think the controls is an issue and obviously needs to be addressed. So anyway, give it some. We'll put that in comments, but it would be a useful mitigation if the ISO is able to manage it. Obviously, making sure that the controls of the POI are are where they're supposed to be, because that should happen anyway. So, okay, thanks for that.
Susan.
That's all I have.
We'll think about that, you know, and I think, you know, it is interrelated because we want to make sure we don't go above the interconnection rights, but no matter what, even if the controls are working perfectly. But your point's well taken. We'll think about that. That may be a way to perhaps, you know, maybe mitigate this issue in the interim for the stranded capacity piece of it. So we'll think about that and see if there's a way that we could, you know, functionalize that. But thanks for
That'd be great.
There's another question in the room. Go ahead over here. Yep, thanks, Susan. Mike.
Hey, this is Mike from CPUC. So going back to Susan's point and calling on my years of experience from having worked at the ISO, when you get into a situation where a resource is operating outside of its registered range, then you're in a situation where the resource doesn't have a bid that correlates to where it's operating, and you start to get into some complicated settlements implications at times. Like that's probably not something you want to risk doing on a regular basis without seriously thinking through the settlements implications. And those are the kind of things, just, you know, the years that I've worked here, the number of times that, you know, how do we settle this thing that's operating in a range where there's no bid came up many different times, and it was almost always because somebody was losing money that they didn't think they were supposed to be losing, or something was going wrong. So you don't, there's some real dangers in that, especially trying to think of that as like a normal operating thing.
Yeah, thanks, Mike. I think that's a really good point, and something I was also going to kind of mention, but you obviously have more experience in that realm. So, yeah, I think if we were to go down that approach, then folks will still have to think about that too. There could be some, you know, financial implications there as well if you start deviating from, you know, your awards, going above, you know, what the market thinks you're really supposed to be doing. Those sort of things, you get deviations and that stuff. So, good point. Thank you for that. Any other questions, comments on any of this stuff? Operator, anything else? Any other questions on the phone?
Nothing on the phone at this time.
All right. Let's move on. Let's get into the, there we go, Ancillary Services section of the discussion today. So a little bit of background. Hybrid resources can provide ancillary services. They're NGR, mixed fuel type. Co-located projects are able to provide ancillary services if they can meet their individual certification requirements for those generating units. Obviously, they have to follow the Appendix K certification provisions, and all those are in Appendix K, so you go ahead and take a look at that if you're wondering about them. And I think the idea is that, you know, even these single resource IDs should be eligible to provide ancillary services, provided that it can meet all of those provisions. So with that, we have some proposals and discussion on what we need to do to allow for this. Right now, we have the, you know, current implementation says they can provide it, but there's some issues that we think, you know, with the actual implementation that we need to adjust and address. So it's essentially around the idea of getting enough information to ensure that we have the knowledge that these resources can actually provide what's being awarded to the market for AS. Because obviously we have ancillary services, payment rescission, or AS no pay is another frequently used terminology to explain that. So if you can't actually provide what you've been awarded, in our settlements process, there's a number of different tests we do where we can claw back those revenues if you don't actually have the capability to provide the services that you've been awarded. So now that we are adding in this idea of you can provide us a forecast of your overall hybrid resource capability, that would include, you know, the opportunity for you to provide AS. If we are actually going to be able to award that AS, we need to have a way to actually apply these other payment rescission provisions as well. So to do that, we're proposing that you have to have an additional set of data, including the telemetry and forecasting of any of the VER component, state of charge of the storage component. So some of this discussion we had earlier about, you know, folks wanting us to kind of understand what's happening behind the scenes. If you actually want to provide AS, we are proposing you will have to provide that sort of thing. We're not proposing that we would be optimizing that resource or the use of the underlying components based off of that information, but we would be using it to actually do this check to make sure that you can really provide if you've been awarded some AS. and then, if appropriate, we could apply that payment rescission. So what are we talking about exactly? What do we think we really need to be able to do this? The first one is what we're terming a plant potential forecast. We talked a little bit about this idea at the issue paper stage with the stakeholders. And the idea is that we're proposing that these hybrid resources have to be able to provide the overall plant potential forecast for the VER components of the resource. And that'll be a new data point that we'd have to, be able to pull into our systems, particularly for the settlements part of it, for this AS no pay concept. The next one is the storage component state of charge. So if it's a resource that has storage component, we need to know really what the state of charge is on that storage device at any given time, so we can ensure that the combination of that plant potential and the state of charge of the resource can actually provide the capabilities that it's been awarded to provide for that AS. So those are the two big pieces that we're proposing right now. Essentially, we need that to be able to ensure that we can do that AS no pay. So that's at a high level the proposal. Let's see if we got some discussion in the room. Go ahead, John.
Yeah, sorry, on slide 42, you say current data on state of charge, and same question for plant potential. Sorry, is this a dynamic feed, like it's constantly updated to you, or is it every 5 minutes? Or
sorry, that wasn't really clear on this slide. I meant today we get the state of charge information from NGR resources, but what we're saying is we also want to basically essentially extend that to the NGR components of hybrid resources. But yeah, what we'd want to know is like the up-to-date telemetry on what the resource could do. And I think the granularity of that would need to be like, in the same type of time frame as what the other overall resource forecast would need to be, if that makes sense. That's kind of the thinking at this point. Okay, any other questions on this concept at all? No. Anything on the phone, operator?
We do have a caller in queue. Caller, your line is unmuted.
Yeah, Susan Schneider, Phoenix Consulting. Very quickly, the plant potential, I'm not sure I understand the definition of that. So if you go to slide 41, yeah, well, actually, I think I'm off. I printed out the slides yesterday. I think there's different amounts. But where it says plant potential forecast, yeah, that one. Okay. What is the definition of plant potential for a renewable? Is it you're not getting a forecast? You're getting what does it mean?
Well, that's something that we're trying to develop right now. So I think we're open to input at this point. I think our initial discussions are essentially we need to know how much the renewable energy component of that resource can really produce at any given time. Similarly to how much we would know the state of charge of the battery would allow it to really provide. So, I think that we need to probably define it in a way where we're thinking about the installed capacity or the Pmax of that component of the resource or something of that nature, and then have the overall potential of that VERS output be forecast like it would be if it was, say a standalone resource. And then have that be its, plant potential forecast for this purpose. So I think it gets really complicated when you start to think about, okay, what if you oversize that comparatively if it was its own standalone resource? What do you really mean by plant potential? I get where you're going with this, Susan. I can tell exactly what you're thinking, but I think we need to refine it, and this is just our initial proposal. So any thoughts or feedback on that?
Well, yeah, the installed capacity you already know, and if they're supposed to, depending on how you're going to structure the outage reporting here, you may know how much of it is functional at any given time, so you would know that. But without doing a forecast for the resource, which you say you may not actually do, and if they don't, even on a voluntary basis, maybe you would offer it, but they would not sign up. I'm not sure how you'd be, well, anyway, I guess we'll wait and see what happens, but it wasn't obvious, so I'm glad it was it was unobvious, not just to me, so thank you.
Well, sure, but I think it's important that we explore this. I think we can refine it more as we go forward, but if you're going to provide a resource level forecast for a hybrid resource, you're going to have to know what the renewable component can really do as part of that. That's why we said we want to have the met station requirement. extended to these hybrids as well. So, you know, the idea, it shouldn't be that foreign. I think we're trying to, you know, basically just ask for the underlying component capabilities at any given period. But it is a bit of a question of what does that really mean for a VER component. And I think, you know, like, for example, let's just take a simple example. We can make a bunch of complicated ones that would be hard to figure out. But a simple example, let's just say it's a 50-megawatt solar component and a 50-megawatt battery. And, you know, we want to know, and maybe the battery is, you know, 4 hours, so it's a 200-megawatt-hour battery. We would want to know the state of charge, how much megawatt hours is in that battery at any given time. We'd want to know how much the actual renewable component is. So if that renewable, that's a 50-megawatt renewable, could only be doing 35 megawatts at any given time, we'd want to have that forecast of just that part of the resource provided to us. So that would be the plant potential of that VER component of the resource in this sense. Now, it gets more complicated if you were to say, you know, well, I'm oversizing that and I really only have, you know, some smaller amount of the renewable that we're going to really, you know, be actively using for this or something like that nature. And so we need to really, you know, think about some of those more complicated possible, you know, scenarios as well. But I think at its face, this is what we're thinking. Okay. Hopefully that helps a little bit. And there's a couple of questions in the room. Go ahead.
Okay. So plant potential is just a forecast of what the VER can do. I mean, just sort of like what the EIR forecast would be if you had one of those things, except you don't.
Yeah, that's fair. I think that's fair. And we could change the terminology if that makes more sense. But I think, you know, we want to differentiate it a little bit from just the traditional EIR forecast because we're saying we're not going to do that for these resources, and it would be like a self-provided type of forecast. But, you know, to the other discussion we had earlier, there was folks that said maybe we should just provide that capability. Maybe we have this proposal that we have to have the underlying component data and information, then maybe we say you have to also have the ISO forecast for those underlying components, and then we could use that as the number for this, something like that nature I think might work.
Well, right now, even EIRs can self-provide a forecast, okay, or, you know, they're not PIRs, they can self-provide a forecast. And so this would sort of be, so while you're looking for, it sounds like here, you don't have to call it something different. I think that's what's causing some confusion. What you really want is the equivalent of an EIR forecast, whether it's provided by the ISO through maybe a subscription service if you decide to offer that, or just the way that any other scheduling coordinator for a resource like a variable resource would provide a forecast.
Yeah, I think that's fair. You know, the terminology we can work on, but put that in your feedback. We got a couple questions in the room, and then we'll come back to you if you have any other follow-ups, okay?
Yep, I'm done.
Grant in the back. Okay, thank you.
Yeah, this is Grant McDaniel with Wellhead. So, Chris, this kind of gets back to I think with the plant potential as well as just the forecast in general, I think it does depend on whether you're coming in and modeling as a generator, or as a VER that's been hybridized, or you're coming in modeling as an NGR. Because if you're an NGR, your ability to do ancillary services is going to be based on the SOC that you're showing on your battery, right? And if you're going to be as a generator, then it's going to be, well, how much you turn down off of your forecast that you provided. And I think it's that straightforward if you look at, well, what are you modeling as?
Mm-hmm. Yeah, I think that it does depend on the modeling, so that's a good point. I don't know if it's 100% straightforward because I think there's still perhaps some interaction. Let's say you are modeling as an NGR and you have the capability for, you know, the state of charge is perhaps the main idea of what the capability of the resource is, then perhaps the VER component, if you combine the storage with a VER and model as an NGR, then perhaps that would be something that might have some impact on the overall, you know, quote-unquote capabilities of the resource, I think. So we have to think through that again, and so that'll be another layer of nuance we need to get into, but a fair point to think about. So thanks for that feedback. Go ahead over here.
Hi, this is Bora from 8 Minute. When you say plant potential, is it plant potential in terms of a time series of data? Or are you looking for basically what the plant is capable of producing that day, like, you know, we have inverter outages, et cetera, right? Or is it like plant potential, let's say I send it to you at noon today for tomorrow, 24-hour period, and I say, this is what I think I could produce given the forecast that I have now?
I think it's more of the former, not the latter. So again, it's going to probably be, what your resource can really be doing up the most granular that we can really know. So, the most up-to-date forecast, so, or the actual, output capability at any given time. Maybe there needs to be telemetry. Maybe it's not necessarily an actual forecast, but maybe there's like a telemetry piece that we have on the resource, where we're taking in the actual amount of energy that could be flowing into the inverters. Or something of that nature. So I'm not exactly sure how to answer that question at this point, but I think it does need to be something where it's more specific, like a time, snapshot in time type of a thing, so we know what's the capability. Let's say you're awarded for a 5-minute period for AS or 15 or 30 minutes or whatever. We would want to know what your capability was really at that given moment, not like what you had forecasted the day before, what your output might be. Go ahead.
So I guess another way to think about it, you want to know the headroom. So if we've been awarded reg up or spending reserves, then you need to know, here's what you're producing at right now, and here's the headroom I have available.
Yeah, essentially, what's your actual headroom available?
This is slightly different than the forecast in bid that we've made because we've bid energy and we've bid ancillary services. This is just, is it easier just to call it headroom?
Maybe that is the right. Maybe we have to say what's the headroom on the VER component only. That might be a better terminology for this, perhaps, because maybe it isn't actually a forecast. So it's really what is the real true capabilities at any given snapshot in time. I think so. I think that is a good point. We'll think about how to maybe clarify that. But I think definitely include these kind of ideas in the feedback, written feedback as well, because we'll use that to develop the upcoming proposals. So thanks for that. Any other questions in the room? Let's go to the phones again. Anybody on the phones, operator?
I'm not showing any calls at this time.
All right, thank you. Okay, let's keep moving forward. Okay, so this is we had a lot of discussion on this already, and I kept saying, oh, wait until we might have already, had a lot of this discussion, but the idea basically is, in addition to this concept for simply having this available for AS and having all these underlying components being provided in the headroom, plant potential, state of charge, whatever components we actually need to be able to know what's really going on behind the scenes, what we're saying is right now it's only going to we're only going to provide that to, we're only proposing to have that for the hybrid resources, but we're not saying you have to have some additional burden on the co-located projects because they're already going to have those requirements in place already. So right now, if you're an NGR resource and under this co-located project type of an approach, you're going to have separate requirements that NGR still has to provide a state of charge, just like it would today if it was a standalone resource. A VER component would have to provide its forecast, just like it would a VER resource, those kind of things. So that's really what we mean here on this bullet, and then I think we're going to get to frequency response stuff next. So, and actually the discussion about maybe extending this requirement for the hybrid resources to not only those that provide AS is going to be in the next section, so I apologize for that. That's going to be in the metering and telemetry section, so even later than what I said. But let's get into the frequency response thing. So this is really the only major modification that we're proposing right now beyond just the no-pay stuff, so related to the actual frequency responsiveness capabilities that we would get from hybrid resources. So what we're proposing here is it's specifically related to some of the modeling discussions kind of that we've heard a little bit earlier. But right now, essentially, we think that we have to extend a minimum sizing requirement for hybrids where they include a storage component to ensure that storage component is actually of sufficient size to really provide the frequency response to make it equal to what it could be able to do if it was, just a normal thermal resource on its own. At least that's the initial intent that we were thinking about. So really, to kind of put a finer point on that, what we mean by that is, if it's going to be a gas and storage hybrid that's modeled as a traditional resource, it will still have that governor response capability. So you don't need to have like a minimum size storage in that modeling approach. You'd still just have to be able to have the overall resource meet that governor responsive capability that's included in the Appendix K requirements. And then if you have a similar gas storage hybrid resource, but now it's modeled as a NGR, it's going to have to meet the requirements of a resource that has a frequency responsive device. In other words, since it has an inverter on it, it doesn't have a governor anymore. It still has a governor behind there, but behind the scenes, but we're modeling it like it just has essentially an inverter frequency type of responsive device. So to do that, what we're really going to propose is that you need to have a 10% of the overall certified size of the ancillary service capacity be made up by a storage device. So essentially, if you were a 50 megawatt combined hybrid resource and you were modeled as an NGR, you would have to have 5 megawatts of storage behind that to be able to provide the equivalent amount of frequency responses you could do if you were just a traditional thermal generator. So the intent just behind this overall concept is that to be able to provide equivalent frequency responsive capability and responsiveness between any of these different type of hybrid resources, essentially. So that's really the idea. And I talked with Grant a little bit about this earlier, but before the meeting, and that's why we got a little bit more detail here in the slides than what's in the actual proposal itself. But this is the intent that we're going to pursue for future proposals as well. And I thought it was worthwhile to kind of include this discussion today. So any thoughts on this idea or questions? I know that was a lot. It might be a little bit complicated for people. But that's the major change that we're envisioning for, at least for these gas and storage combos for the hybrid resources on ancillary services. Any questions? Anything? All right. Anything on the phone, operator?
Yes, we do have a caller in queue on the phone. Caller, your line is unmuted.
Yeah, hi, Susan Schneider, Phoenix Consulting. I'm just wondering where the 10% number came from.
So, so the 10% number is based off of the calculations that it would actually be required to provide the equivalent amount of frequency responsive capability as a similar sized traditional thermal generator.
Okay. Are you going to provide the calculation?
Yeah, so this part isn't in the proposal in writing at this point, the 10% requirement. We just said we might need some minimum sizing requirement. So for follow-up to this, in our subsequent revised draw, we will include a formula that backs up this need to explain how it would be equivalent to traditional thermal capability if you have this 10% requirement. But it's a fair question. Thank you.
Okay, that's great. And just to make it clear, this minimum storage requirement is not a requirement for any other resource besides the gas plus the storage hybrid.
Yeah, at this point, that's what we're thinking, because that would really be the only kind of resource that would have that kind of need or that requirement. But I think, if we add, this capability for another hybrid that's a VER and a a VER and a storage component, we might need to extend that minimum sizing requirement similarly.
I'm sorry, Jared, what?
Well, the thing is I'm not exactly sure about how that will apply when you're talking about, like, let's say 2 inverter-based resources, like a VER and a storage device. I think that those have the capability to provide, more immediate responsiveness. So I think you got to think about that. But, it's something to be clarified in future proposals.
Okay, but it's not part of your proposal right now.
No, it's not.
Okay. All right. Thank you.
Back of the room, do you still have a question? Go ahead.
Yeah, just a comment on that, Brian from Z Global again. So we've been looking at that minimum size a little bit differently in terms of the NGR's ramp rate and what it could provide in, for example, for spinning or non-spinning reserve. That might be a little different. Just food for thought for the ISO to consider the ramp rate in that, maybe not necessarily associated with frequency response, but for reserves, we think the energy storage needs to be sized appropriately with the ramp rate so it can bridge that time before the unit actually comes online.
Okay, I'm taking a note of that. Thank you. We'll have to think about that. I think that is a good point, too. Yeah, because if you're providing reserves, we would still want that resource overall to be able to provide that with the same amount of capability as it would, a traditional resource, and that ramping capability might be something that maybe we have to require specifics on. I'm not exactly sure. Go ahead, Grant. Do you have any thoughts on that?
Yeah, just a quick comment on that. The ramp rate's already considered within the rest of the Appendix K requirements and your criteria as far as, your maximum output in 10 minutes time. When you look at the totality of all of the criteria, that ramp rate your ramp rate would have to be considered in order to make it for that amount of spinning reserve. But the frequency response, here it was just appropriate to spell out that there are two different varieties, whether or not you're coming in showing yourself as a gas resource or an NGR. They're going to be different. So depending on how you're going to bring your resource in, you want to plan appropriately, because you're going to have two different droop responses, essentially, right?
Yeah, and that's a little bit more technical than my understanding, so I'm going to defer that to our discussion in the next proposal. But, definitely encourage folks to provide that feedback in their written comments so we can have more discussion on some of our other SMEs here in the ISO, and then, put out something with a little bit more granularity and specification for the next proposal. All right, so thanks on that. Any other questions on the phone, operator?
We have no further questions on the phone at this time.
Thank you. Okay, so that moving us along to the metering and telemetry section. And this one's pretty straightforward. I don't think this will take a lot of discussion, but again, it's a little bit related to some of the other things we've already talked about, essentially. So it's a bit of overlap, I would say. So for this part of the discussion, we just wanted to, again, reiterate that we are going to require this additional telemetry and other data that might be necessary for the AS certification piece of it. So any hybrid resource that includes these different components will need to provide the various information, plant potential or headroom, state of charge, telemetry on each of the components to be able to provide the ancillary services. So that's what we are thinking about. But we're also thinking this is kind of the discussion we were getting at a lot earlier in the day about really, do we need to require this for all these hybrids or not? And so that's the question we're posing. What we think is it might be necessary to require that we get all of the underlying component information from all hybrids all the time. And so there's many stakeholders mentioned something about this earlier. And that was what I was alluding to. But essentially, we need to do things such as, forecasting our expected renewable production on a 5-minute basis. We need to be able to commit resources to meet all of our NERC requirements and performance standards. We have things like our state-level renewable energy policy tracking that we need to do, things of that nature. And then, potentially maybe some of the other more nuanced needs might be in the future. NERC may require modeling of the more granularly of the underlying components of hybrid resources, but that's not a current standard or anything. But we're trying to think about that. And at this point, we again, kind of to the earlier discussion, we don't necessarily have a proposal at this time to do so, and we wanted to make sure that if there was going to be additional costs, that this was justified, that stakeholders were in agreement with us. So essentially what we're doing is just putting out this as an idea, a concept, and seeing if stakeholders support the concept, if they oppose it, what their feedback kind of is overall on this idea. And then we may come back with a proposal where we actually say, yep, you're going to have to just provide all this stuff. In addition to the idea that you would provide us a normal forecast for the overall hybrid resource to be used in the market process, maybe we need to know the underlying components as well. So that's really the idea that we're seeking feedback on. So we didn't propose that as an actual requirement yet, but again, just seeking feedback. So with that, any questions or comments on that idea? I know we kind of already hit on that a lot, so maybe we can skip over that. More of that discussion. It looks like it. So let's keep moving. Let's keep moving on. If anybody has anything on that, let us know. So let's see. The next couple slides here. I have 4 new slides on the metering configurations that people could use, and this basically comes off of or comes from the workshop that we did previously earlier this last month, and we had some discussion with stakeholders about the different metering configurations, how it worked, if you were a hybrid resource, and there was a lot of discussion, good questions, and so we took the opportunity to clarify. There's these 4 different scenarios, and these are all for hybrid resources only. If you guys want to know more about the different capabilities that we have for metering configurations, I'd urge you to go back and look at the issue paper and look at that presentation that we had posted for a prior workshop, that technical workshop that we had on metering and telemetry. Those will have all the different the diagrams in place, and that should provide some good background there. But let's just go through these 4 different new clarifications that we wanted to make based off of what we learned from stakeholders in our discussion during that workshop, that online workshop that we held. So this one, and again, our metering folks aren't actually in the room today, so I might not be able to answer questions on these in super nuanced fashion, but I'm happy to take those questions offline with those other SMEs. But I'm going to do my best to give you at least a high-level description here. So again, we have 4 new different clarifications that we want to make. This first one is for a hybrid resource if you're going to do high-side metering, where you're also having the capability of charging from the on-site generation. So essentially what this does is it says you're going to have the ability to only charge the storage device from the on-site generation. You're going to have a limiting scheme that's going to have to be in place to prevent charging from the grid. And then the high-side meter, which is indicated by the green box at the top here with the dots in it, essentially on the high side of that transformer, is going to be where you measure the resource output for settlements and any RPS reporting if it's RPS eligible resource. The next one is similar, high-side metering, but again, this one has the capability of charging from both on-site and from the grid. So the storage device, again, can charge from both, but so it doesn't have to have that limiting scheme to stop it from charging from the grid. And then the high-side meter, again, is going to be at the overall high side of the transformer. And then this one notes that you might have to have a second meter here to be able to do RPS reporting. That's actually indicated by the second meter there near the solar panels. The next one we want to talk about is low-side metering with charging from only on-site generation. Again, this is for hybrid resources only. So the storage device would only charge from the on-site generation, not the grid. So again, you have to have a limiting scheme here. You're going to have 1 meter on the low side of the transformer. Again, that green box with the dots is the meter here in this diagram. And then lastly, hold on, okay. And then the last one we wanted to provide is the low-side metering with the capability for charging from both on-site and the grid. So similar to the high-side one, you're going to have 2 meters, but again, this one, the battery can charge from on the grid or the on-site generation, so there's no requirement to have a limiting scheme for charging, but you're going to have 2 meters to be able to calculate the RPS reporting requirement, I think, is the intent here. So you have 1 meter at each, the battery storage device and then the solar panel as well. So, and then this would work for if you had, different resource components that were, wind and storage or things of that nature as well. So those are the clarifications we made or we wanted to provide on the diagrams for metering. Any questions on that stuff before I move on? Okay.
You have 1 question over the phone.
Sure, go ahead, thanks.
Caller, go ahead, your line is unmuted.
Hi, this is Azir from First Scholar. I had a question on slide 50, essentially for when you're saying it can be charged only from the on-site generation, and there's a limiting mechanism to prevent charging from the grid. I was curious, does this include aux loads for the system and the battery as well? And how do you account for that in the meter?
I don't know how to answer that question. Deb?
Yeah, this is Deb. It includes, yes, it does include your aux load and it's accounted for in the metering as part of the true-up of what you can put onto the grid. Right, we include the losses behind.
Sorry, go ahead. Sorry.
We include the aux load and losses behind the meter as part of the determination as to what you get for POI.
Okay. All right. So, it's included in it. So it's included for the in this section. We wanted to include aux loads. It would be fine for just having one meter, correct? Okay.
Correct.
Okay. Thank you.
Thanks, Deb. Okay. Any other questions on the phone, operator?
We do have one more question over the phone. Caller, go ahead. Your line is unmuted.
Hello there. This is Jerry Melcher with the Public Advocate Office here at the CPUC. Earlier this week, there was a mention at a Rule 21 meeting of a new, I believe, ANSI working group to develop the DC metering standards. I believe their first meeting is next week. It's somewhere in Minnesota. Didn't get many details. Perhaps Sophie Meyer in the Energy Division might have more details since it was her meeting. So that's the update.
Hey, thanks for the update. I appreciate that. That was something we talked a little bit about earlier. But, yeah, to kind of recap again, just for listeners that have joined us as well, the current status is that we don't have any DC certified meters, ISO DC certified meters, and there aren't any of those. I think it's I forget the term he used, but ANSII or whatever it is, essentially the group that certifies the meters standards. I think they're also thinking about that as well. So I do appreciate that input. It's good to know that they're working on that. That might help facilitate the DC configurations that some folks are. So thank you. Okay, let's keep moving forward. I want to talk a little bit about the RPS reporting. This was something that we, talked about with stakeholders a little bit, and we thought maybe you have to have, multiple meters and things of that nature to be able to provide accurate RPS reporting. And then we had some other discussions. So on a couple other related items. But basically, a little bit of background, again, we talked about this during the issue paper, but right now we are registered with WEC as a qualified reporting entity. So we do provide all of the QRE, the RPS data on behalf of any ISO metered entities into the Regis application, which is the way that they track this RPS reporting. And so, essentially what we're stating here in the proposal is that we believe all the current metering configurations can be accurately represented or accurately calculate the actual representation of how much RPS production is actually going to be occurring, and we can still provide that to the Regis system through our current, processes. And so, we had, in the issue paper, we had said, hey, we might need to require some new type of configurations or calculations or something of that nature. But really at this point, we're thinking that the current ones are flexible enough to be basically designed in a way and implemented in a way that we can ensure we can meet any of the needs for this RPS reporting. So what we're proposing is really that we would just work with the developers as they configure these type of hybrid resources and ensure that the metering and any calculations to net losses or any of the other related calculations like that. Last question about the auxiliary load and such were all addressed and accounted for so we could get accurate RPS reporting. So that's where we are on that. If stakeholders think there's something we need to address there, we're open to suggestions, but we think that that's appropriate. Now the next item I wanted to talk about is the storage conversion losses. So we heard a good deal of input during both the discussions previously, the issue paper and our metering and telemetry workshop that we held, that some entities or stakeholders think that they disagree with the idea that we shouldn't be calculating losses for the conversion of of storage. So, renewables that are, being used to charge a storage device, there's some losses associated with that conversion. The CEC's RPS guidebook says that we have to calculate those losses and net them off of the RPS production. Some stakeholders said we should, change that, but that's really outside of our purview, so we're just stating here that we're not intending to change that through our process, and that, we're going to have more discussion with the CEC, and if stakeholders are interested in that treatment, we would, point them in that direction. We will have some discussion with the CEC to make sure that all of our processes align with what they're expecting, obviously, so we can talk with them and, express those concerns, but that really is not something that we're going to propose to change through this process. So I'll pause there, see if there's any questions, comments on RPS reporting needs, the storage losses issue, or anything of that nature. Anything? No? Looks like we're good. Online? Okay, yeah, go ahead.
We do have one question over the phone. Caller, go ahead. Your line is unmuted.
Yeah, hi. Susan Schneider, Phoenix Consulting. Just wanted to be clear. So if you have a co-located resources under two separate resource IDs, are you still going to treat them as two separate resources for RPS reporting, or are you going to treat them as together as one?
Yeah, so I believe those ones would have to be treated separately. Okay. So I don't think we would report any of the battery output or storage output as RPS eligible.
I'm sorry, the store. Okay, so the VAR output would be reported as RPS eligible, and you would not subtract anything because they happen to have storage on the same, the same connection.
Correct.
Okay, thanks for that clarification.
All right, thank you. All right, so.
And
go ahead.
We have another caller join the question queue. Caller, go ahead. Your line is unmuted.
Hi, this is Mike Toomey with Recurrent Energy. I'm just thinking about some of the metering schemes and also what was just referenced about it being treated as two different facilities. I have concerns with the applicability of the ITC credit when this is supposed to be considered one combined facility if we're treating it as two different producers of energy for reporting purposes within the CAISO. I think that there's going to be some conflicts there. That's one, and then the other is I think that there are a few different metering schemes that you show that are going to be tricky to demonstrate that there are losses in the system that are for some reason still producing RECs. In particular, I think slide 53 was a good example where there was a meter in front of both. On the low side, the meter for the solar does not know whether the battery is charging, and therefore no losses will be associated with that structure, and so RECs will be generated, but at the meter or the at the POI, I'm assuming that there would be one in this scenario that is separate from what's showing here, would not reflect the same output as the RECs generated.
Yeah, and that's why we were indicating that that would need two separate meters, because if you have a meter on the battery side, then you can actually calculate how much was actually absorbed by the battery, and then you can determine essentially what the conversion losses would be. You'd have the amount of solar that was coming off and how much was coming and charging off of the grid. But I think that you're right. You might need to think about how perhaps we need to have another meter maybe at the POI here. So I think that that's a good point to maybe think through a little bit more, where we might need an additional meter to really be accurate on the RPS, but I'll have to think through that some more, and I'll talk with our metering folks. But does that response make sense to you?
Along those lines, I believe it was slide 51 that has a different metering scheme where there are two meters. Yeah, I believe 50 and 51 are very similar, and it makes a lot more sense to me not to have a meter in front of the solar panels, but rather a meter in front of the storage in this scenario. A similar setup to this, but where you only have two meters, but one for the full output of the plant, and the other meter is specifically tied to the battery, not to the solar, because the solar will be calculated via the aggregate meter, But on the battery side, having a meter there would be important for confirming the round-trip efficiency losses of the battery. So you're not just relying on the battery management system, but also on the meter that would reflect the energy going in and coming out of the battery, whereas you don't need that necessary flexibility on the solar side of it. And then I think that was one iteration of metering scheme that isn't showing here, and I think the one that makes the most sense to capture all the relevant information.
Yeah, and I actually think maybe to extend that a little bit, I would guess we might still have to have another meter on the solar panel in addition to also on the battery here in this scenario, so you could see how much was really being produced by the solar, how much was being charged off of the grid, how much was going from the solar into the battery versus how much was actually coming off of the grid and going into the battery. So I think we do need to work on this a little bit more as far as all these different possible configurations. So, you know, again, our intent with the overall proposal is that we would work with developers to ensure that the way that they're set up would actually meet the metering requirements and reporting requirements, RPS reporting requirements particularly. So we will think about that a little bit more. And again, my metering SMEs aren't in the room at the moment, but I think that we could probably solve some of this if we maybe put together some simplified examples, perhaps some numerical examples, try to figure this out. And maybe we need to provide some more clarity, maybe some more diagrams or other options. So thanks for the thoughts. But I think it might be a little bit more complicated than what some of these slides are making it out to be initially.
Thank you.
And then, yeah, and I would just respond on the ITC thing. I think, you know, as well, I think that is a good point that some folks have also raised, but I guess at this juncture, we're not really of the opinion that folks can't get capability of qualifying for that. Again, is what we've heard from some developers, but that's really going to be, you know, something that the developers are going to have to determine on their own outside the ISOs, you know, and I think so. At this point, we think we can still allow for that, but it is, you know, something to be seen, and everybody's going to maybe have their own individual preferences on how they want to deal with that. So let's keep moving on to the RA section. Actually, I'll pause and see if there's any final questions on any of this metering, telemetry, RPS-related stuff. Operator, any final questions on the phone?
No questions at this time.
All right, let's move on. Okay, so RA, this is going to probably be an interesting topic. Everyone's interested in how these resources are going to provide RA. Resource adequacy is also a pretty big component of the economics, a lot of resources, so it's going to be important, and obviously the ISO relies on RA to ensure reliability, so also very important to the ISO as well. So a little bit of background. Okay, yeah, let's hold on. Okay, so before I start talking about this, let's go to the phones. Is there someone that still has a question on the prior discussion, or is this about RA? Operator?
There is no further question. I take that back. Okay. On one moment.
Okay.
Caller, go ahead. Your line is unmuted.
Thanks. Sorry, just to go back over metering, if we could look at slide 51, this is Dave Carter from the SHOTS Center at Humboldt State University. So can you explain why it wouldn't work to just do a single net meter on the high side for this configuration, where you basically you'd be tracking your RECs would be generated based on the net export from the site?
I'm going to have to defer the question. I think it might be possible, but Deb wants to answer. So go ahead, Deb. Thanks.
Yeah, you can do that. It's on slide 50.
Oh, okay.
That's only when you're charging only from on-site, not from the grid, though.
Correct.
Yeah.
That's only when you're charging from on-site. But
right. Yeah, the question would be.
And the reason why.
You know, sorry, go ahead.
The reason why on slide 51 the meter is over on the solar panels is because you could be charging from on-site or from the grid. And so if you're charging on-site or from the grid, from a CAISO perspective, we just need to know what the solar panels are doing. We don't care what the battery is doing, and that's why there's not a meter over the battery side.
Right, and you know, I was just in looking at this. If you just had the single meter on the high side, then you did the net meter at that point. So all the export from the site would be a result of the solar, and the customer would absorb all the losses. Or the developer would absorb the losses and whatever you're exporting.
Well, isn't there a possibility that the export, instead of being the solar, could be the battery?
Yes, but you know, and so the battery, that could be stored solar energy, you know, or it could be grid energy stored from the grid, but the net of it would always be, the net export would always be the solar component, because that's the only actual generation that you have on the low side.
But that would then limit the project to only producing during the daylight hours, if you're assuming it's solar, versus I understand a number of the projects that are solar that are pairing up with batteries want to be able to extend their ability to put generation on the grid when the sun is down.
I think you can capture that with the netting, though. I think that's his point, is that you could, in that scenario, if you had the output of the solar panels, you know, you have this, the overall netting at the POI, you know, that I think you still have to have 2 meters on, not exactly sure. I think you have to have at least a meter to know exactly how much the solar is put out, because the fact is that the generator, the storage battery could be charging from the grid, and you'd have to net that out overall. But I think, you know, Deb's point is that basically you'd need to know how much solar was produced at any given period and how much battery production was happening based off of that netting calculation. So anyhow, I think we do need to clarify this, but again, our folks from metering and settlements aren't actually at the moment, so sorry we can't give you a more thorough explanation, but I think we will work on trying to maybe provide some more clarity on this as we go forward.
Thanks. So we'll try to provide more clarity in some written comments as well.
Okay, yeah, thanks. And I think we'll try to do some of those numerical examples like I mentioned, and maybe that will help clear some things up as well. I think that could be useful.
Thank you.
Okay, thanks. Let's keep going forward. So now let's move on to the RA discussion. So a little bit of background for folks, just in case you're not all up to speed on how RA really works. Okay, so this is just going to be real brief, and I might kind of gloss over some facts, but if folks don't understand anything about this, let me know, and I can go into a little bit more detail. But the key concepts we wanted to explain to everybody is that you have essentially to provide RA, you have to know how much the resource is worth, which is what we refer to as the RA counting rules, and their qualifying capacity. And then they also have to have a must-offer obligation. And so what the must-offer obligation is essentially how much you really have to participate in the market, or how much you really have to provide the ISO with bids to meet your essentially your resource adequacy requirements. So we have a part in our tariff that defers to the local regulatory authorities for the qualifying capacity rules. So how do you actually count the rules? We have default QC methodologies in our tariff right now for the RA resources for all the various, you know, technology types or generation types. But then we do defer to the LRAs. So, for example, the LRAs, like the CPUC is the main LRA for California, that produces the QC list every year, or the qualifying capacity list for the values of how much each resource actually qualifies for meeting, for providing resource adequacy. So once they do that every year, they publish this list after they do all their calculations. Then the ISO actually takes that and does a deliverability study, which sets up an output for each resource called the net qualifying capacity. And so that's also referred to as the NQC. And we publish an NQC list every year as well. So once the QC and NQC is established, then resources can be used to meet RA requirements. They can be shown to the ISO on the RA plans and supply plans. So LSCs that contract for capacity or own capacity provide it and show it to the ISO as RA on an RA plan, and then suppliers that own the capacity also provide a supply plan, and then we cross-validate those and say, yep, okay, LSC over here has been sold some generation from the supplier, and they said that they provided it, and then we actually validate that and say, okay, now you have qualified RA capacity that's been shown for the month or the year, and so in association with that, then you have to have an offer obligation to provide bids for those resources to be made available to the CAISO's markets. So that's at a high level of basically how RA resources participate in the market. And why are we talking about this here? Because it's really important for these hybrid resources to get an RA value and a must-offer obligation so that they can also participate and help contribute to CAISO RA and CAISO reliability. And also because developers are going to want to make money off of RA as well. So right now there is no qualifying capacity approach counting rules for these hybrid resources under single resource ID. We went and talked with the PUC, and we supported having a interim methodology where you essentially add both of the underlying resource QC methodologies and put those together, and then that would be the overall qualifying capacity of these hybrid resources. So when we were discussing it at the PUC, we obviously talked about, storage and solar, or a VER component and a storage component. And so to do that, as an example, we would use the ELCC approach, which stands for Effective Load Carrying Capability approach, which is a type of statistical calculation that's used to determine the output of VERs, or the VER component potential RA value, and then the PMAX 4-hour duration, source sustained output duration of the storage. So you'd add both of those figures together, and that would be your overall qualifying capacity for these resources. And then to get to the net qualifying capacity, obviously that's going to be subject to deliverability. If we do a deliverability study, that might give you a little bit of a haircut depending on your location in the system and the amount of congestion in that area and upgrades that are necessary and that sort of thing. And then we always cap the overall the overall net qualifying capacity of resources at their interconnection capacity rights. Again, we're talking a lot about this at the level of the VERs and storage combined, but we're also just saying overall, as a default QC methodology for hybrids, what we're going to propose to include in our tariff is just that we have an additive approach of the underlying technology types. So, be it thermal or storage, VER, hydro, whatever it may be, whatever different combination essentially for these hybrids under a single resource ID, we would have just simply those underlying components calculated and added together. So that's the major proposal for the RE counting rules that we're trying to pursue. One thing to note, obviously, is important is that idea that we do defer to the local regulatory authorities on how to do counting rules. So if we put this in our, tariff as a default methodology, it would apply if the PUC doesn't do anything and doesn't actually, determine their own qualifying capacity. So we're also working with the PUC on this as well to try to have them adopt a similar approach. So, and I think other entities, I think SCE has proposed something similar to this in that arena as well. So we are working on that. And I think that that's something that hopefully gets done sooner than later. Go ahead, John.
Yeah, so on that front, is this an item that needs to wait until Q2 of next year to go to the board and then move forward, or is there some general consensus with stakeholders to have this be kind of the default? Can that be fast-tracked? It might just assist with projects that are getting developed today.
Yeah, I think that might be something to think about, how, maybe we could move this to, like draft final proposal and go to the board sooner, perhaps something to consider. But again, if we do that and then we get it in place and then the PUC goes and does something different, that would overrule that anyway. So there's a bit of uncertainty there, essentially at that kind of dynamic there. So the default queue thing might be great to do quickly, but I think what we're hoping is that everyone urges the PUC and that we work with them and quickly through their process, because they could get it done sooner. Perhaps if they do an expedited process and then they put out a new order in their RA proceeding that would establish this through their process, that would be able to be done perhaps quicker even than us going to the board early on this. So a lot of kind of moving targets here on this one.
No, that's fair. And then my other comment is I'm not sure PMAX is the right term on this slide, only that you'll have you have a 40 megawatt 2.5 hour battery, so 100 megawatt hours. So as far as sustained is 25, but technically its PMAX would be 40, right?
Yeah, maybe it might need to be just a 4-hour duration issue. I think that might be the more clarified way. So I think we need to think about exactly how we're using that terminology. But the way that the storage is, just standalone storage, is they're like 4-hour duration output, sustained output capability. So that would be, that would be right. So I think it would be, that would be the way we would probably think about it for the future proposals.
Yep, perfect. Thank you.
Yeah, thanks for that. That's a good clarification. Okay, any other questions on the phone? We got some on the phone. Oh, you're going to read off that one? Okay, go ahead. Thanks, Jimmy.
Yeah, thanks, Chris. Operator, I'm not sure if we have anyone in the queue, but I do have a question from Jan Strack, who wasn't able to stay on the whole call from SDG&E. He wrote, if the quote combined hybrid resource only permits the storage to be charged from solar, doesn't that necessarily limit the QC value of the combined hybrid resource to something less than the simple sum of 1, the ELCC-based QC of solar, and 2, the installed capacity of storage? Seems to me that any behind the POI operating constraints that apply to the combined hybrid resource should necessarily limit the QC value to something less than the QC value where there are no operating constraints.
Yeah, so that's a good question, and we did have some questions, similar questions about this very issue when we were talking about it at the PUC workshop. I think some of the PUC staff themselves were a little bit concerned with this concept, and then they were saying, well, hey, if you use the ELCC of a VER and then the storage component, you just add those together, but you're during the middle of the day you're actually charging the VER or the storage component off of that solar, then you're really actually reducing the ELCC value of the VER component. So I think, there is some validity to that concern, but we need to think about how does that really impact the overall ELCC of these VERs. I think that at this point, we're hoping that this is, a good interim approach, and then there might be some more nuance around this. Maybe there's a way that you could do an ELCC of both of these components. And so I think that's something we also heard discussed at the PUC a little bit as well. So that's certainly a good question. I think at this point, we're not thinking about doing something more intense where we would do like an individual ELCC for each of the resources, because again, I also want to note that when the PUC establishes this ELCC approach, they do it for the whole system. So they look at what are the overall ELCC of all solar, what is the overall ELCC of all wind, and then they apply that to all the resources. So it's a much more of an approximation methodology than an exact ELCC of each of the individual resources. So I think that kind of on average overall, we can kind of maybe get away with doing this kind of a more of an approximation approach and still be able to ensure we get a certain amount of the overall capability from the resource in a way that's reliable. But definitely something more to think about. I'm going to go behind you real quick because Grant had his hand up first. Go to Grant and then back to John.
Yeah, Chris, I heard that question just a little bit differently, so I want to kind of rephrase this. the ELCC plus VER, or ELCC of the VER plus the 4-hour max makes sense in all conditions, because if you knew you were coming up on a peak day, you could say, well, you know, solar I want you completely output, and battery you charge off the grid, and then we'll get the full amount of the RA capacity. You could meet that if you knew it on a day-ahead planning. But I think the question that was raised was, but what if the battery can only be charged from the solar? If you have that instance, then you on that peak day, you can't have that maximum output from both of them, right? And so in that configuration only, this wouldn't work.
I don't know necessarily about that, though, because I think
the solar in that case.
Well, yeah.
It's
a metering. If you're saying you can only charge the battery from your solar, then on that peak day, I can't have charge from the grid my full battery and have it ready to go, and you know, coincident with the VER output, right? Because all your VER output has to go in the battery is not available. So I think the question that was raised, you know, on the line is one to consider. It may be different from this.
So I'll respond then in kind. Everybody else can get a chance. I know everyone's chomping at the bit for this one. So I think I would disagree with that, Grant, because I think the key is that ELCC is based off of the 24/7, 365, that 8760 output of that resource. So that means that on that day that you said, you know, oh, you can never get the full output of that resource, you can get the full output of that resource during the times when there is a loss of load expectation. You can actually move energy from the peak of the day. You could be storing energy when there's enough other solar output out there that you don't really need the energy from that solar component of this hybrid during the peak period during the day, and then move it into a period later in the afternoon or evening and have the output of the storage and solar. But again, I don't think you're going to get that full amount of output at any given time when the solar is obviously going down. So there is something to be said on that. So I think it does depend on the size of the battery, perhaps, and there might be some different use cases that we need to think about. There's a lot of nuance here. So this is just our initial proposal, and I think we're open to ideas. But so that would be my initial response to that. But it is very complicated when you think about the interactions between these things. So John was first, then I'll go over here to you.
We're going to say the same thing, I'm pretty sure.
Okay.
So the other thing to think about here is how we're designing and optimizing the plant. So we're in the process of building a peaking solar plus storage project for another Desert Southwest utility, right? So part of that design is it's not a 4-hour nameplate battery. It's a smaller battery because we know we can use some of the solar output to meet their peak window, and then we can maximize how the battery is dispatching to carry us through the rest of their peak. Same thing's going to happen here. We'll have the battery charged as a priority on days where it's likely that it's going to be needed for RA, and then we can manage the dispatch between the solar output that remains and then how the rest of the shape is going to occur. So we're able to leverage some of the solar and the battery. So you may end up with, again, that idea of a 40-megawatt, 2.5-hour battery, because we can, and it looks like 25 megawatts to you to RA, but we're actually dispatching it more like 40 so that we're maintaining our production window when the solar is occurring. So I think there's a lot more nuance to it. I think this approach does work in the context that we're setting here. I don't know, Bor, if you want to.
Just want to add, I mean, that's one example, the peaker plant. The other one is basically what I would consider a baseload plant, where it may be a 100-megawatt interconnection, but the solar behind it is designed to be something like 170 or 200 megawatts. And just to make the curve flatter, and then to use the clipped energy that would be clipped to charge the battery. So just because it's a 100-megawatt interconnection doesn't mean the solar behind it is 100 megawatts.
Yeah, and that was somewhat what I was kind of getting at as well. So I do think there is a lot of complication when you think about this, and we'd probably do well to have like a whiteboard discussion with a bunch of, examples and drawing the energy curves during the middle of the day and that sort of thing. We could really get into this in a lot of depth, but I think at this point, this is what we think for at least an interim solution would work. But, to Grant's point, again, to try to, also provide the other side of the coin there, the point is that it is important to think about is if you are really charging that during the day, if it's not really like oversized, as the example that Amen Energy has provided, if it's not really oversized enough to essentially, provide that full output of the expected VER component of the resource, throughout the middle of the day, then you are going to impact the overall ELCC of that resource, even if you're taking some of that energy in during the middle of the daytime, rather than moving it to the times later in the day. So I think this is not a perfect solution by any means. We need to think about the different iterations or different types of configurations that we might see with these business use cases that folks want to utilize these resources for. And maybe the PUC will come up with something that's differentiated based off of different use cases or different, maybe sizing of the battery and ratio of the battery to the storage or to the solar component or VER component or things of that nature. So I think there's more to come on this, but this is I think we believe this is a good initial proposal of how to do the counting. So go ahead, Doug.
Yeah. No, I just wanted to say that I appreciate your observation that the ELCCs, if I understand correctly, are really taking a look at what happens when that class of resource comes out to the loss of load expectation. And for hybrid resources, if we are getting into this like very specific details of use cases and what's charging when, that's just a very different methodological approach. And really to stay comparable, what we need to do is take a look at if we remove storage from these hybrid resources as a class across the entire all hours of the year, what is the impact on loss of load expectation if we're going to stay consistent with the concept behind the ELCCs in general, and without getting into whether that concept is a good one or not.
Yeah,
so and compare apples to apples if we can.
Yeah, and I think that's a fair point, and I would note that my understanding of the PUC's approach right now is that they have proposed that for the next year we will be looking at the interaction of storage at the whole system level, and how much that creates some dynamic synergy and what they're calling a diversity benefit between the storage components moving or being able to shift energy from the middle of the day until later. I'll admit it's a little bit more nuanced when you talk about these hybrid resources when they're behind the scenes of one interconnection, and I think that dynamic now maybe changes the calculus on that overall. But that's something that I think is going to be really difficult for the PUC to figure out. So we're going to have to see how that all shakes out at their proceeding, I think. Go ahead, Doug. Sorry, Grant.
Yeah, Grant McDaniel. I just want to qualify. I think that the ELCC, your VER plus your 4-hour storage is the correct method, and I don't have any problem with that. It was just that the question was raised was, does that apply when you only charge your battery from your solar? Because in that case, you're limiting your fuel that you can put in the battery. So if I can charge from both the grid and from the solar, then they are additive because I have unlimited fuel from the grid, and I have whatever is available from the storage. But in the case where you're only going to be charging from the solar, you've limited your fuel, and you can't double count that. And so it was just that one specific instance where I don't think it works. Otherwise, I'm total agreement. It works.
Okay, that's fair. Yeah, please include that in written comments, and we'll think more through that and try to respond directly to that issue for our future proposals. Okay, so on this slide, we'll go to the phone in a second, but on this slide, we just provided a simplified example here, a numerical example of that proposal from the previous slide. So if you were to, combine the solar and storage, assuming you had a 44% ELCC value for the month, and a 100-megawatt facility, that would be worth 44 megawatts of ELCC. The 4-hour sustained duration of 100-megawatt, 400-megawatt-hour battery would be 100 megawatts of QC, and then you add those two together, you'd get 144 megawatt QC. So we just wanted to provide that. That's included in the proposal just as an example. Perhaps we need to think a little bit more about maybe adding some more examples, fleshing this out a bit for future proposals. But this is kind of just to, to provide that for, illustrative purposes here. Okay, so let me go through this part, then I'll pause for more questions. So the RA counting rules for co-located projects, again, so not the hybrid resources, but the co-located projects with the 2 or more resource IDs. Right now, we think that that's pretty straightforward. Generally, obviously, you're just going to have the existing QC approaches for each of the underlying resource IDs, and so it doesn't create a big barrier or anything like that. You can already get RA for these, so this might be one reason why folks want to move to doing this kind of an approach. But we do think that there is one concept that is important to think about here, which is how do these co-located resources with this interconnection constraint or interconnection rights limit actually need to be addressed. And so we think that right now it's pretty easy under the current approach where we have this, possible stranded capacity situation. Basically, right now, the Pmax of each resource limits the QC of the overall resource. So if we said, you have 100 megawatts of interconnection rights, then obviously either of the Pmax, the combination of those two couldn't be above that. So we would limit it, and we would ensure that it would be within their connection limit. But this gets a little bit more complicated when you add in this concept of interconnection rights constraint that we were proposing, because under that approach you would have the true Pmax of each of the resources reflected in the master file, which means that now that good approach that previously would have limited that QC is no longer going to actually occur. And so what happens, or what we're thinking about, is that we need to have a way to address this under these new interconnection constraints that we're proposing. So to do that, we think that there's a couple options that we could use to address this. The first one would be the PUC could work with developers and figure out how to split these things under their QC process, and they could do it and limit it to the POI. And obviously the CAISO would probably work with them and provide a list of all the resources that were under these interconnection constraints and such to be able to allow for that kind of a PUC process. We haven't had this discussion thoroughly with the PUC to ask them if they would be willing to do such a thing. So the alternative we're also thinking about is, perhaps the PUC might not want to deal with doing that, and so they could still just do the normal QC list without worrying about that, base it off of their normal QC approach, and then they would obviously have an additive QC that was above, perhaps above what their interconnection rights were, which would be problematic. So we would, be able to address that through the CAISO NQC list process, where we would just do a double check and make sure any of these resources that were under an interconnection constraint would actually be reflected and limited through our NQC process. So that's what we're thinking about now. Hopefully that's pretty clear to folks what we're intending here on this, but I'll pause and see if there's any questions on this or any other discussion so far on the counting rules. Anything? Operators on the phone?
We do have a few questions over the phone.
Go ahead.
Caller, go ahead. Your line is unmuted.
Hi, Susan Schneider, Phoenix Consulting. I think that the issue, first of all, it says there's two options to address this issue when you've got three bullets, but it looks like the last two bullets are a single option. Is that right?
Oh, yeah, sorry. Yeah, that's okay. Intended to be. Yeah,
okay.
two bullets for one option.
Right, okay. And then the question here is you've got a situation where you're going to have co-located resources. It's very likely that you're going to have some deliverability, particularly where people have added storage after their interconnection studies. You've got a new framework now where you can transfer deliverability from one resource ID to the other. And that's a CAISO rule. And so I'm wondering how, it seems logical then for the CAISO to be the one to do the split, because if you're going to allow deliverability back and forth, that's just not something I don't think that is really in the CPUC bulwark at this point. So I think that's, there's great interest in this ability to transfer from what the resource was originally studied for to storage. And so I think that just works better if the ISO is the one doing that split.
Okay, yeah, we'll take that under advisement and think about it a little bit more. Thanks, Susan. Oh, okay, hold on, Susan. Go ahead, Deb.
Susan, just a question back for you. Yes, we do allow the transfer of deliverability status, not of QC or NQC. So we need to be a little bit careful. Okay.
Yes. Yes, I understand that, but still, it's again, that's not something that I think the CPUC discussion so far doesn't seem to have that nuance in it, and So they would have to they would sort of have to incorporate that deliverability transfer in doing QCs for each resource and in that framework. It just seems more logical since you've already got the framework in your tariff to do it that way. So I don't know. I understand it's not QC back and forth, but that's another reason why the ISO maybe could make the final adjustments here for each.
And I would just respond that I think that that's perhaps a fair statement, but I also would be a bit concerned with how does the PUC view these resources being contracted for RA, and if we were, maybe the ones to be, establishing this relationship or interrelationship, then it might not necessarily match up with what the QC that the PUC thought was actually occurring or was being sold or contracted for or otherwise was actually occurring. So I really need to have some more discussions with the PUC on this as well. But we'll definitely think through it further. But this is just our initial.
Okay. What would be really helpful is if in your next version, and we'll put this in comment in writing also, it would be really helpful if you could. You do look at a couple of different scenarios with I know co-location is not the big focus here, but to look at the different, if a resource started as a hybrid, how would that work? And if you were doing a deliverability transfer, how does that sort of flow through here? It would just be good to get some more practical examples of how that could all work.
Yeah, I think that's good. I would encourage you in your written comments to put in, maybe just some hypothetical examples as well about what you think you would like us to do to provide some response to. That would probably help us give you more what you really are looking for, Susan. That would be great. Thank you.
Okay, that's fair. Sure. Thank you.
Yep. Thank you. Okay. Let's keep going. I think there might be some more questions on the phone. Operator, go ahead.
You have another question over the phone. Caller, go ahead. Your line is unmuted.
Hi, this is Joseph Aboliman from the California Public Utilities Commission, Office of Ratepayer Advocates. I think I understand the concept of your imposing limits on the resources to be interconnected for both the hybrid and the co-located resources, but I don't understand why. Why is ISO putting a limit on this, putting an interconnection constraints on these resources?
Yeah, thanks for the question. So we have to limit the overall RA of these co-located resources. So if there's two resources behind a single POI and they have more, capacity or more capability than their actual interconnection rights, we can't give them RA above that interconnection rights when we combine both of their qualifying capacities. So that's really what we're talking about here and why we need to limit it, because they've only paid for network upgrades to actually be able to inject a certain amount of energy onto the system. So to limit their injections to that, we can't also give them a similar or a larger amount of RA credit than that.
Okay, now what about the hybrid? So does the same concept or rationale apply to the hybrid resources, where you're also imposing some interconnection constraints?
Yes, it does. It does apply. So, again, we would also limit their overall interconnection to their overall QC values to their interconnection rights, as you can see here on that second italicized bullet. What we're proposing. So, we have to make sure that even for those resources, obviously their overall, underlying components could be above their interconnection rights, but that they're going to have essentially established a PMAX, the limit in the overall process and an interconnection capacity injection rights that's limited. And so, if they paid for the full amount of capability that they had, then their, interconnection rights wouldn't necessarily limit their QC, but if they're, an oversized resource that's a hybrid under a single resource ID, they would still also be limited the same way as two co-located resources. There's just a different dynamic as far as there would just be one QC value here as opposed to under the co-located, there's two, where you have to make sure that the combined two QCs don't add up to above that interconnection right.
Yeah.
Thank you for the question. Okay, operator, anyone else on the line for questions on the phone?
No further questions at this time.
Okay, thank you. So we're going to go on to the must-offer obligations. So this is getting close to the end of the day today. So this one is probably one of the more interesting components that we'll talk about related to RA. Again, as I noted earlier, once you're shown for RA, you have a must-offer obligation associated with that resource. And what does that really mean? You have to make your resource available to the CAISO because we need to have those bids in our markets to ensure we can dispatch the resource and use that for reliability to maintain our resource adequacy and then, you know, meet load during all the hours of the year. So we have to also establish that since we don't have any QCs for these hybrid resources, we'd also, you know, in addition to establishing the QC, we'd want to establish a must-offer obligation. Now, this is one where there's, you know, distinctly in the ISO's jurisdiction in our tariff is the must-offer obligation. So whatever the PUC decides, we're going to also have to establish through our tariff how these resources actually participate in our markets through this must-offer obligation requirement. So first things first, the co-located resources, the must-offer obligation for those ones is relatively straightforward. You have a separate and distinct must-offer obligation for each of those resources. And, you know, we're just wanting to clarify here one of the things, the big thing we heard from some of the discussion during the issue paper is, you know, some resource developers said, well, oh, you know, these co-located resources, you know, I can use the storage resource to meet the you know, the award of the solar sometimes, or I can meet the solar resources RA obligation by bidding in the storage resource or something of that nature. So the smaller bullet on the bottom here, sub-bullet, just to specify and clarify that you cannot do that. If it's if it's a co-located project with two resource IDs, they're treated as completely separate. Cannot meet the must-offer obligation of one resource with another resource. So that was something we wanted to make very clear through this process. We're not intending on changing that. That's just how it is. And, you know, we understand that people want to try to operate these things, you know, in a manner where they could be coordinated some way. If you want to do that, you're going to have to go with the hybrid resource, single resource ID approach. So we wanted to specify that. Now, with that, we wanted to let's move on and talk about the the hybrid resources. So again, since there's no move for those, we're proposing we establish the must-offer obligation through this initiative. We just talked about the default QC methodology that we would do. We also proposed, and, you know, discussed earlier the proposal for the provision of a self-provided forecast from these hybrid resources to be used in the CAISO markets. So what we're also proposing is to set the move for these hybrid resources at their self-provided forecast, essentially in a similar way to what we have today for the VER resources, where they just are required to bid up to whatever their forecast it really is. So that's just the concept at a high level at the outset for here in our straw proposal. And we think that this should be able to provide some flexibility for those provided forecasts, but is necessary really because there's not really another good way of actually approaching the moves we think for these resources that would have a self-provided schedule or self-provided forecast, excuse me. So that's the concept here. And then just to reiterate a couple points, that proposal about the self-provided forecast obviously is going to be for only those resources with like a VER component in there for a hybrid. And so this would only really apply similarly to those resources that have that self-provision of the forecast. If it's a thermal and storage resource, then we would expect that resource would have a QC methodology, that would be the combination of both of those. They could probably provide a must-offer obligation 24/7, like similar to just a traditional resource like they would today. So there's a little bit of nuance there on this, that this variable must-offer obligation would essentially only be for hybrid resources with a variable energy resource or a renewable energy component to it. And then this slide, just a little bit more kind of related to some of the discussion that Mike had mentioned earlier about the day-ahead markets and that participation. So what we're thinking is, you know, how do these really need to be established? These resource offer obligations need to be established in the day-ahead and or real-time markets. There's some moving pieces here that we want to try to discuss a little bit, but our initial proposal is that, yes, you will be required to participate in the day-ahead market, similar to other traditional thermal or traditional dispatchable generation, because we're essentially treating you as such. So if you can provide that self-provided forecast in the day ahead, you would have to participate. Similarly, if you've been shown for RA and actually bid in the day ahead market. So the other thing I wanted to mention is that the real-time market is a little bit different. Right now, you know, a VER resource essentially has only a must-offer obligation in the real time based off of its forecast. So, you know, there was some discussion about, do we just do that for these resources as well? Is it really like that, or is it more like a traditional thermal or a traditional type of generator, dispatchable generator? And, you know, we're still thinking a little bit about that, but there's also this concept of the day-ahead market enhancement design that we're talking about, and also some of the other related RA enhancements provisions that we're thinking about how to really integrate all these concepts that we're thinking about right now. And one of the things in the day-ahead market enhancements is to simply move to kind of an RA obligation only in the day ahead, and then have some other products. And, you know, if you get awards in the day ahead, then you'd have a must offer in the real time. We have imbalance reserve proposal as well. So there's some other concepts related to how do RA resources participate in our markets that are kind of up in the air right now that we're thinking about doing. So we just, you know, wanted to make sure that folks know that we're going to coordinate any of these RA offer obligation proposals with those other ongoing initiatives as we move through this process as well. So that's all I have on the must-offer obligations. You know, these things are definitely complicated, so we're still thinking through some of it, but that's our initial proposal. Any thoughts, questions, concerns? Sure, go ahead.
This is Michael Volpe from PG&E. Is the hybrid team aware of what's going on with the CCE3 initiative and the clarifications and the proposed tariff language, which seems to be going the opposite direction of this? It was proposed to be more restrictive as far as whatever is in your RA supply plan, you have to meet on a 24/7 obligation.
Yeah, I've been somewhat familiarized with some of the discussion that's going on there. I think that that's kind of intended to be included here, and any of the other active stuff that we're working on being reflected. But I think what we're intending here is to try to provide the most flexibility that we really can. But I think that there's some other reasons of why we're wanting to do those other CCE3 changes. But I'm going to have to discuss that a little bit more with our team that's working on that and see how that interacts with this and if there's any concerns there. But thanks for raising it. I think that's fair to ask. You know, if we're going one way in one initiative and perhaps conflicting, we want to make sure we don't, you know, create any incongruities there. So thank you for that. I'm going to take a note of that. Okay. Any other questions? Grant, go ahead.
Yeah, just a comment. First of all, super good job on this whole straw proposal.
Thank you.
Just thinking out loud here, so forgive me. I think both in the RA counting as well as the must-offer obligation, I think what we're missing does get back to the consideration whether somebody is modeling as a generator or an NGR. Because in both instances, in both an RA counting and must-offer obligation, I think they're going to be different if you're modeling as a generator versus an NGR. In the example that we were talking about earlier about if you had a hybrid where you were only charging from your solar, you're probably going to model that as a generator. So its RA count is going to be different, and the must-offer obligation is going to be different. If you're doing an NGR, then you're going to be charging, you're going to want to show it, you know, you're charging from the grid, And obviously, you're going to have that RA counting of both components, and your must-offer obligation is going to be different, which is aligned with what you have here on the slide. I just think that differentiation, when you get to the next iteration, your treatment of it will make a little bit more sense, if that makes sense.
Yeah, I think it does. Excuse me. I think that's a good point. We do really, I think, need to clarify exactly what would be the different moves, if there does need to be a differentiation between them, if it depends on the modeling of the reason. Again, if we're going to have, I think we still need to explore, like, for instance, if you model as an NGR and you're providing us a forecast, are you going to be providing a negative forecast? How are we going to really incorporate that into our market processes? And then beyond just that part of the discussion, then it means, then do you have to provide a bid for discharge and charge capability now, and a forecast, and so they get a little bit more nuance there. Some of the things we have to think through further. So it's a very good point. But thank you for the feedback and the appreciation of this proposal at this point. I think we do need to do that, though. There's some more work to be done on a lot of, but I appreciate the feedback. So thank you, Grant. Any other comments in the room? How about on the phone, operator?
We do have one question on the phone. Caller, go ahead. Your line is unmuted.
Yes. Hi. Susan Schneider, Phoenix Consulting. I had a question about the day-ahead versus the real-time must-offer obligation. If you've got a resource that is, and maybe this is kind of in line with the earlier comment about what are you modeling mostly as, but if you have, say, a 150-megawatt project that has a 30 megawatts or 40 megawatts of storage, and 150, and the rest of it is variable resource, it seems like it's still mostly a variable resource. And so to force that kind of resource to have to put in a day-ahead schedule and have a day-ahead must-offer obligation when it's still mostly a VAR, even though I know it's not officially that, but it's still mostly variable resource, seems sort of, I'm going to say unfair. That's not really the right word, but not necessarily appropriate. So it seems like if you've got a huge amount of storage relative to your variable resource, maybe that's more appropriate for a day ahead because that's what storage would have to do. But if you're mostly still a VAR, it seems like maybe the obligation should be mostly based on that. And maybe it should still just be a real-time must-offer obligation.
Yeah, thanks for the thought,
make a difference here.
Yeah, I think it's a good point, and my thinking on it would be, we have thought about that same question, so it's not new to us. We're still thinking through how to really address it, but kind of go back to some of the questions about how do you treat the RA counting rules and the qualifying capacity rules, and how we're saying right now we just have this one proposal for how it should be done for all these hybrids. And admittedly, I think that might need to be broken down into perhaps different types. I think that in this instance, you may have a very good point that they might not really be able to provide that much certainty of how they can participate in the day-ahead market if they are mostly a renewable or mostly a variable fuel type of a resource under these hybrids. There might need to be a different must-offer obligation for those ones. But I would also say if that's the case, we probably need a different counting convention for those resources as well. So I think those resources would not be able to count as similarly as they would if they could really provide as much flexibility like a traditional dispatchable resource. So I think that there's some stuff to think through on all these concepts that are very interrelated, and I think we might end up in a place, I'll just guess, we might end up in a place where we have multiple counting methodologies and multiple approaches to the must-offer obligations depending on the different configurations. That may be where we ultimately end up.
Well, I think what I just said actually is more, your hybrid resource counting actually is consistent with the mix of the resource, and so it will adjust naturally if a resource is more of one thing than another. That would be reflected in the RA value, so that's actually very consistent. And yet this basically says everything has to be just one way. Even if you have just a little bit of storage or, a lot less storage. And so I think what I just suggested was actually more consistent with what you're suggesting on the hybrid counting methodology. That will adjust naturally for the mix of the resource, whereas this basically saying you're forced in the day ahead no matter what your mix is, that's not consistent.
Well, honestly, Susan, at this point, I think we kind of have both. There's some validity in both of our views on that, I think. And frankly, I'm not sure I would totally agree that they're exactly consistent in the counting convention concept and also the must-offer obligations. I do see your point, though, that there is some relationship there to the counting convention and being a little bit different, and then applying a similar MOO for all the resources in the day ahead and real time. But I think it does really depend on maybe the overall ratio of size of storage to a renewable, things of that nature. And then also maybe some of those questions like what Grant was getting at, maybe if you can only charge the battery or the storage device off of the on-site generation, maybe that has another impact, and maybe there's something that needs to get reflected in the counting and the must-offer obligation. So certainly not an easy thing to nail down here, and we are kind of out in the deep end. Nobody else really has thought about this stuff or has any precedent as far as this goes across the country. So we're just starting to think through this, but I think you have some good thoughts there to help stimulate the discussion. So thank you for that, Susan.
Okay.
All right, thanks. Any other questions on the phone, operator?
No further questions on the phone at this time.
All right, one more chance for anybody in the room. I thought this would be a much more lively discussion than what we've seen today, so we might be because I did it at the end of the day and so everybody's ready to go home or whatever. But yeah, if you guys do have thoughts about these concepts, please, obviously we seek a lot of feedback and hope that you can provide that in written comments, so we would appreciate that as well. So to wrap up the day, one more. Okay, good, cool. Go ahead.
Just in the spirit of asking a question, I'll keep it quick. This is Mayhole for solar. So the sentence there about requiring resource participate in the day-ahead market from the hybrid setup, how would you enforce that? Would you use a default bid? If so, what would be the proxy price, and how would ISO?
All good questions, yes. So those are kind of going towards what I think Mike had mentioned earlier as well, how this would really participate in the day-ahead market. Beyond just that, then you get into, okay, wait, now you have a MOO. How are you really going to enforce that? Are you going to do bid insertion? Are you going to have default energy bid? What are you going to do for those resources? And I think we're thinking through that still. So I don't have a good answer for you at this point. But very good questions. Please include those in your written comments too. And then I think for the next iteration, we'll have some more nuance on that sort of thing and get into how do we really envision these really participating in the day-ahead market, what kind of requirements we would need to have in place for like cyber rules or things of that nature. So thank you for that question. It's very, very good. Sorry, I don't have a better answer for you at this point. Okay, so the last bit I wanted to cover was the implementation schedule. We already talked about it a lot today throughout the process because it's obviously very important to developers and stakeholders alike. So just to recap again, this last bit we wanted to provide was, what we're intending for the policy is to get a comprehensive policy that's completed in Q2 of 2020 and brought to the board. Hopefully that can provide some certainty for developers and participants as soon as possible. I think, John had a good suggestion about maybe some of these things might be able to move sooner than others, so we'll talk about that internally. The implementation plan, as far as, beyond the policy, after we go and bring this to FERC and get approval, implementation target is right now it's fall of 2021. We also note here that there might be certain tariff items that could be implemented before that, where there might not be a technology or a system upgrade that we would need to do, or systems impacts, such as like the default QC methodology, things of that nature that would just be more of like a tariff requirement that we think might be able to actually be implemented maybe perhaps before that time frame of fall 2021. And then I think we heard some other discussion. Susan had some good input about maybe we could do some things in the interim to maybe mitigate some of the concerns about the stranded capacity, things of that nature. So, I think there's probably a lot of good ideas from stakeholders about how we could address some of the implementation, issues interim approaches to doing things. If you have input on that, we definitely welcome it, and you know, we will consider those kind of things, and maybe we can refine this a little bit. So this is our initial proposal for how we're going to complete the policy and implementation. So that'll be it for me, but I'll pause here and see if anybody has any input on this implementation or anything like that. You know, I think we had a lot of discussion on it already, but if there's any thoughts, you know, obviously also just include in your written comments too. Let's go to the phone, see if there's any last thoughts, operator. Anybody on the call?
No further questions on the phone at this time.
All right. I have a feeling that people probably want to have some feedback on this implementation stuff, so we'll just look forward to that in our written comments. With that, I'll turn it back over to Jimmy to wrap this up.
Thanks, Chris, and thanks again, folks, for joining us as we wrap up today a little bit early, give you some time back. We are asking for written comments, as mentioned earlier, by October 21st. It's about a 4-day extension from the original posting of the paper. We got to give you guys more time, I think, because the paper was posted a few days later than we had intended. So hopefully we can receive those by the 21st. Great discussion in the afternoon. We did touch on the ancillary services, resource adequacy, and metering and telemetry. As mentioned for ancillary services, basically extending the current requirements to the hybrids and to the both components of the co-located resource. And then we did explore the Planck Potential concept, and a good suggestion to maybe terminology change there for calling it headroom to reflect the full capacity at any given point in time, sort of different from the forecasts. Then we noted you know, the difference between inverters and governors for frequency response for both generators and batteries. And then for the extending the metering telemetry, we're not sure yet if it will apply to all hybrids, so it's sort of still a question in development. And then the metering, we sort of continued the last discussion. Hopefully we cleared up the examples and any further suggestions on that. We are curious for your input on that. And still accounting for the storage conversion losses for the CEC requirements. Hopefully that's made a bit more clear this time around. And then limiting the QC for RA requirements is still a question. And as Chris noted, implementation might have to you know, roll out this proposal in phases, but more exploring on that as we develop this. And once more, thank you. And as mentioned, the recording will be available within the next couple of business days, so please look out for that as well. And save your day, of course.
That concludes our conference. Thank you for using AT&T Event Conferencing Enhanced. You may now disconnect.